Hello and welcome. This is Michael Annis, and you're listening to episode 18 of the Space Rocket History Podcast. And now, Luna 2 and 3. While the Mercury 7 were fulfilling their roles as symbols of space exploration, Korolev once again was offering the real thing. In September 1959, he proceeded to orchestrate a 1-2 punch at the moon. The first punch would be Luna 2, sent to impact on the surface of the moon. The second would be Luna 3, sent to photograph the far side of the moon. Luna 2 would be the second of a series of Soviet spacecraft launched in the direction of the moon. Luna 2 was similar in design to Luna 1, which we covered in episode 15. Luna 2 was a spherical spacecraft, 0.9 meters in diameter, weighing 390 kilograms, with protruding antennae and instrument parts. Luna 2's instrumentation was also similar to Luna 1's. It included scintillation and Geiger counters, a magnetometer, and micrometeorite detectors. There was no propulsion system on Luna 2 itself. Luna 2 also carried Soviet pennants. Two of them, located in the spacecraft, were spear-shaped with the surface covered by identical pentagonal elements. In the center of this sphere was an explosive for the purpose of slowing the huge impact velocity. This was designed as a very simple way to provide the last necessary reduction in velocity for those elements on the retro side of the sphere to not get vaporized when they impacted on the moon. Each pentagonal element was made of stainless steel and had the USSR coat of arms and the Cyrillic letters CCCP on one side and the Russian words USSR September 1959 engraved on the other side. The third pennant was located in the last stage of the Luna 2 rocket, which was planned to collide with the moon's surface 30 minutes after Luna 2 did. It was a capsule filled with liquid and aluminum strips. On each of these strips, the USSR coat of arms, the Russian words 1959 September, and the Russian words Union of Soviet Socialist Republics were engraved. In order to track Luna 2's trajectory, the spacecraft and its final stage rocket, which accompanied it to the moon, were equipped with radio transmitters so that Earth-based receivers could measure the trajectory using the Doppler effect. Like Luna 1, Luna 2 was tracked using optical telescopes as well. To make things easier, the launching rocket was to release clouds of sodium gas, which glowed under the influence of the sun's radiation. Luna 2's sodium discharge would be achieved by exploding a thermite charge, which had been mixed with sodium metal. This was planned to occur at a distance of 113,000 kilometers from the Earth. The launch vehicle for Luna 2 was a modified R-7 Vostok 8K-72. The Vostok had 3 stages. The first stage and the second stage were the standard R-7, which we covered in episode 9. A 5.1 meter long by 2.4 meter diameter third stage was added to the top of the R-7. The third stage weighed 1,472 kilograms and was capable of delivering 54.5 kilonewtons or 12,252 pounds of thrust. This was the stage that accompanied Luna 2 to the moon. Launch was scheduled for September 9th, but the Block 1 core stage was shut down after it failed to reach full thrust at ignition. The booster was removed from the pad and replaced by a different vehicle, delaying the flight by 3 days. Luna 2, like Luna 1, took a direct path to the moon with a journey time of around 36 hours. This was dictated by the fact that the Earth-Moon gravitational system forced it to follow a curved trajectory, and launch had to occur from the side of the Earth opposite the moon. Its journey time had to be therefore 12, 36, or 60 hours in order to ensure that the moon was above the horizon in the Soviet Union. After a successful launch and attainment of escape velocity on September 12, 1959, Luna 2 separated from its third stage, which traveled along with it towards the moon. On September 13th, the spacecraft released its sodium gas cloud. The cloud expanded at a rate of 1 kilometer per second, attaining a diameter of 400 kilometers before it became too faint to observe. Photographic observation of the artificial comet combined with radio methods made it possible to determine to a high degree of accuracy the bearings of the rocket and to elaborate the further flight plan to the moon. On September 14th, after 33.5 hours of flight, radio signals from Luna 2 abruptly ceased, indicating it had impacted on the moon. Luna 2 hit the moon about 800 kilometers from the center of the visible disk, east of Mare Serenitatis near the Aristides, Archimedes, and Autolycus craters. On impact, it scattered its Soviet emblems and ribbons across the lunar surface. About 30 minutes later, the final stage of Luna 3's launching rocket made its own crater on the moon. Luna 2 made several noteworthy accomplishments. First, it showed time variations in the electron flux and energy spectrum in the Van Allen radiation belt. Second, Luna 2 was the first spacecraft to reach the surface of the moon and thus the first man-made object to land on another celestial body. And third, it confirmed that the moon had no appreciable magnetic field and found no evidence of radiation belts at the moon. On September 15, 1959, Premier Khrushchev presented to President Eisenhower a copy of the spherical pennant as a gift. That sphere is located at the Eisenhower Presidential Library and Museum in Abilene, Kansas. The only other known copy of the sphere pennant is located at the Kansas Cosmosphere in Hutchinson, Kansas. And now the news clip for Luna 2.
Soviet Russia scores a dramatic victory in the exploration of space with the launching of the first rocket to hit the moon. An historic scientific feat simulated in these scenes, which show the course of the multi-stage rocket carrying the 858-pound Lunik. Bearing the Soviet coat of arms and hammer and sickle pennants, it traveled 35 hours through space. It is the first man-made object to voyage from one cosmic body to another. Western observers monitored Lunik's 2 radios to the very moment of impact, which occurred almost dead on target, the geographical center of the face of the moon. Impressive marksmanship at 250,000 miles range. In one spectacular, well-timed move, Russia scores a major scientific advance, dramatically demonstrates the accuracy and reliability of its missiles, and gives Khrushchev a propaganda bonus on the eve of his visit to America. Moscow shot for the moon and scored a bullseye.
Korolev now prepared to undertake the most demanding mission yet. He would attempt to photograph the far side of the moon. Luna 3 required a spacecraft with advanced capabilities. It would have to follow a trajectory of high accuracy. Luna 1's near miss wouldn't work. It would have to orient itself while behind the moon, finding it with a sensor and pointing its camera in the proper direction. Luna 3 then would have to operate an automated photo lab that would develop the film by washing it in chemicals, a refinement with obvious value for military reconnaissance. In response to a radioed command from a ground station, the craft then would turn on a TV camera, scan the developed photo, and transmit their images back to Earth. Luna 3 was a cylindrically shaped canister with hemispherical ends and a wide flange near the top end. The probe was 130 centimeters long and 120 centimeters at its maximum diameter at the flange. Most of the cylindrical section was roughly 95 centimeters in diameter. The canister was hermetically sealed and pressurized at 0.23 atmospheres. Solar cells were mounted along the outside of the cylinder to provide power to the chemical battery stored inside the spacecraft. Shutters for controlling the heat inside Luna 3 were also positioned along the cylinder and would open to expose a hot surface when the interior temperature exceeded 25 degrees Celsius. The upper hemisphere of the probe held the covered opening for the cameras. 4 antennae protruded from the top of the probe and 2 from the bottom. Other scientific apparatus such as micrometeoroid and cosmic ray detectors were mounted on the outside of the probe. Gas jets for attitude control were mounted on the outside of the lower end of the spacecraft. Photoelectric cells were used to maintain orientation with respect to the Sun and the Moon. The spacecraft had no rockets for course adjustment. The interior of Luna 3 held the cameras and film processing system, radio equipment, propulsion systems, batteries, gyroscopic units for attitude control, and circulating fans for temperature control. The spacecraft was spin-stabilized and was directly radio-controlled from Earth. The imaging system on Luna 3 consisted of a dual-lens camera, an automatic film processing unit, and a scanner. The lenses on the camera were 200 mm focal length, 5.6 aperture, and 500 mm 9.5 aperture. The camera carried 40 frames of temperature and radiation-resistant 35 mm isochrome film. The 200 mm lens could image the full disk of the Moon, and the 500 mm could take an image of a region on the surface. The camera was fixed in the spacecraft, and pointing was achieved by rotating the craft itself using the gas jets. A photocell was used to detect the Moon and orient the upper end of the spacecraft and cameras toward it. Detection of the Moon signaled the camera cover to open and the photography sequence to start automatically. The launch vehicle for Luna 3 was a Vostok 8K72, the same as Luna 2. Luna 3 was launched on October 4, 1959, the second anniversary of Sputnik 1. After a successful launch on a course over the Earth's North Pole, the Block E escape stage was shut down by radio control from the Earth at the proper velocity to put Luna 3 into an unconventional, long elliptical orbit around the Earth-Moon system. In order to prevent it from going into orbit around the Sun, Luna 3 was launched with a lower velocity than Luna 1, hence its 3-day rather than 2-day journey to the Moon. Initial radio contact identified 2 problems. First, the signal from the probe was only about half as strong as expected, and second, the interior temperature was increasing. To correct the temperature, the spacecraft's spin axis was reoriented and some equipment was shut down, resulting in a drop in temperature from 40 degrees C to about 30 degrees C. At a distance of 60 to 70,000 kilometers from the Moon, the orientation system was turned on and the spacecraft rotation was stopped. The lower end of the station was oriented towards the Sun, which was shining on the far side of the Moon. As the probe passed over the Moon's south polar region, its sensors picked up the Sun. The spacecraft then turned its bottom in that direction. It remained locked on the Sun as the Moon moved into view of another set of sensors located on Luna 3's top. Responding to them, the craft now turned to face the Moon, locking on and shutting off its Sun sensors. Detection of the Moon signaled the camera cover to open and the photography sequence to start automatically. The images alternated between both 200 mm and 500 mm lenses during the sequence. After photography was complete, the film was moved to an onboard processor where it was developed, fixed, and dried. The film itself was specially formulated so that it could be processed in a high-temperature environment and so the temperature itself was not important. After the film was dried, it passed in front of a television scanning system for images to be converted to a form in which could be transmitted by radio. At all times, the film was shielded from radiation in order to prevent it from being fogged. The camera took 29 pictures over the 40 minutes on October 7, 1959. The distance ranged from 63,500 kilometers to 66,700 kilometers above the surface of the Moon, which covered 70% of the far side. Now soaring high over the Moon's north pole, the craft began a return to Earth along a carefully planned orbit that would keep it in view of its tracking stations at all times. Its transmitter lacked the power to send a clear signal at lunar distances. It would do this only when close to the Earth. The first attempt to transmit the photographs was on October 8th, but it was not successful due to the low signal strength. On the fifth attempt, as Luna 3 got closer to the Earth, 2 noisy photographs were received. Eventually, a total of 17 resolvable photographs were transmitted by October 18th. After its mission was finished, Luna 3 continued to orbit the Earth-Moon system under the combined gravitational influences of both bodies until March 29, 1960. On that day, its trajectory actually took it into the Earth's atmosphere at high speed, where it burned up as a result of friction with the air. Luna 3's photographs did not provide a definitive photo atlas of the far side of the Moon, but they were quite adequate for the first good map that noted principal craters and other features so they could receive names. In this moment of triumph, Soviet scientists picked names with strong international flavor. They honored their own, of course, with such choices as Tsiolkovsky and Lomonosov. But they also selected non-Russian names: Maxwell, Edison, Jules Verne, and Pasteur. And like the great explorers, Magellan and Columbus, Korolev and his people were the first to view this undiscovered world and to see its far side. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.